To estimate the amperage of an air conditioning unit when you know its tonnage and voltage, you can use the following formula: amperage equals tons times 12,000 times 1.1 divided by voltage. Let's break down each component of the formula. Firstly, tons refers to the cooling capacity of the air conditioning unit, typically measured in tons. This value represents the amount of heat the unit can remove from a space in 1 hour. Secondly, the constant 12,000 represents the number of British thermal units, or BTU, per ton. A BTU is a unit of energy, and 12,000 BTU is equivalent to 1 ton of cooling capacity. Thirdly, the safety factor 1.1 is included to account for potential power surges, variations in operating conditions, and other factors that may increase the unit's amperage draw. It provides a buffer to ensure the electrical system can handle the air conditioning unit's load safely. The formula's denominator is voltage, which is the voltage of the electrical supply to which the air conditioning unit is connected, typically 240 volts in many residential applications. To illustrate how to use the formula, consider a 2-ton air conditioning unit operating on a 240 volts electrical supply. Using the formula, the calculation is as follows: amperage equals 2 times 12,000 times 1.1 divided by 240. This equals 26,400 divided by 240, which equals 27.5 amps. Therefore, the approximate amperage of the 2-ton air conditioning unit operating on 240 volts is 27.5 amps. It is important to note that this formula provides an approximate value for the amperage of the air conditioning unit. The actual amperage may vary depending on the specific model, manufacturer, operating conditions, and other factors. For accurate sizing and electrical calculations, always refer to the manufacturer's specifications or consult with a qualified electrician. They can provide precise information and ensure the electrical system is properly sized to handle the air conditioning unit's load safely and efficiently. In practical applications, it's important to consider several factors when determining the appropriate amperage for an air conditioning unit. Firstly, the manufacturer's specifications provide the most accurate information about the unit's electrical requirements, including the minimum circuit ampacity and maximum overcurrent protection device size. These specifications should be followed to ensure safe and reliable operation. Secondly, local electrical codes and regulations may impose additional requirements or restrictions on the installation and wiring of air conditioning units. It's essential to comply with all applicable codes to ensure the installation meets safety standards. Thirdly, the condition of the existing electrical system should be assessed to ensure it can handle the additional load of the air conditioning unit. Factors to consider include the capacity of the electrical panel, the size and condition of the wiring, and the presence of other electrical loads on the same circuit. If the electrical system is inadequate, upgrades may be necessary to accommodate the new air conditioning unit. Fourthly, the operating conditions of the air conditioning unit can affect its amperage draw. Factors such as ambient temperature, humidity, and the unit's settings can influence how much current it consumes. It's essential to consider these factors when estimating the unit's amperage and sizing the electrical system accordingly. Fifthly, the type of air conditioning unit can also affect its amperage draw. Different types of units, such as window units, split systems, and central air conditioners, may have different electrical requirements. It's important to select a unit that is appropriate for the application and has compatible electrical characteristics. Lastly, regular maintenance and servicing of the air conditioning unit can help ensure it operates efficiently and draws the correct amount of current. Dirty filters, clogged coils, and other issues can increase the unit's amperage draw and potentially damage the electrical system. It's essential to follow the manufacturer's recommendations for maintenance and servicing to keep the unit in good working order. Additional considerations include the starting amperage of the air conditioning unit's compressor motor. When the compressor starts, it draws a significantly higher amount of current than during normal operation. This inrush current can trip circuit breakers or overload the electrical system if it's not properly sized. To address this issue, some air conditioning units are equipped with soft starters or variable frequency drives that reduce the starting current. These devices gradually ramp up the motor speed, minimizing the inrush current and reducing stress on the electrical system. Another important factor to consider is the voltage drop in the electrical wiring. When current flows through a wire, it experiences a voltage drop due to the wire's resistance. If the voltage drop is excessive, it can reduce the performance of the air conditioning unit and potentially damage its components. To minimize voltage drop, it's important to use appropriately sized wiring and keep the wiring runs as short as possible. Furthermore, the location of the air conditioning unit can affect its electrical requirements. Units installed in areas with high ambient temperatures or poor ventilation may draw more current to compensate for the increased heat load. It's essential to consider the unit's location when estimating its amperage and sizing the electrical system accordingly. In some cases, it may be necessary to provide additional ventilation or shading to reduce the heat load and minimize the unit's amperage draw. In addition to the formula and factors discussed above, there are several other resources available to help calculate the amperage of an air conditioning unit. Online calculators and mobile apps can provide quick and easy estimates based on the unit's tonnage, voltage, and other parameters. These tools can be helpful for preliminary calculations, but it's always recommended to verify the results with a qualified electrician. Electrical handbooks and reference materials also provide detailed information about calculating the amperage of air conditioning units. These resources often include tables, charts, and formulas that can be used to determine the appropriate wire size, circuit breaker size, and other electrical components. When working with electricity, it's important to prioritize safety and follow all applicable codes and regulations. Always disconnect the power supply before working on electrical equipment, and use appropriate personal protective equipment such as gloves and eye protection. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to ensure the installation is done safely and correctly. Remember, the formula provided is an approximation and should be used as a starting point for estimating the amperage of an air conditioning unit. It's always recommended to consult with a qualified electrician or refer to the manufacturer's specifications for accurate sizing and electrical calculations. By following these guidelines, you can ensure the air conditioning unit operates safely and efficiently, providing reliable cooling for years to come. Understanding the electrical requirements of an air conditioning unit is essential for ensuring its safe and efficient operation. By using the appropriate formula, considering relevant factors, and consulting with qualified professionals, you can accurately calculate the unit's amperage and size the electrical system accordingly. This will help prevent electrical overloads, reduce energy consumption, and extend the lifespan of the air conditioning unit. In summary, to calculate the approximate amperage of an air conditioning unit when you only know the tonnage and voltage, use the formula amperage equals tons times 12,000 times 1.1 divided by voltage. Remember that 12,000 represents the BTU per ton, and 1.1 is a safety factor. Always consult the manufacturer's specifications or a qualified electrician for accurate sizing and electrical calculations.